Hello students, welcome back to the Tantray physics classes. Today I have come up with more challenging problem which is good for IIT, good for IIT aspirants, good for those who want to appear in the national Olympiads. The problem is like this. What is the total heat generated in the resistor after inserting the key? It's a current source, any current generating source, and this current I0 flows, and when the key is closed, the current I flows, and it has two parallel elements, resistance and inductor L, and the current divides into resistor and inductor, and we have to find how much heat is generated in the resistor. First of all, when you insert the key, initially the current through the inductor will be zero. Because there was no flux in the inductor, it will produce induced EMF and oppose the change in flux, and it will not allow current to pass through the inductor initially, because initial current will change the flux, which is not which is opposed by the inductor. It will produce back EMF, and total current will pass through the resistor initially at t is equal to 0. But after some time, the flux through the inductor will try to remain constant, and finally what happens when the flux through the inductor remains constant? There's a heavy current through the inductor, and the current through the resistance will be 0. So initially there is no current through the inductor. This full current passes through the resistor. But finally, what happens? The total current is bypassed by the inductor, because this inductor will be a short when the flux through the inductor is constant, and there will be no current through the resistor. So that means current through the resistor is varying. Its initial value is maximum I0 and final value is 0. So current through the resistor varies from maximum value to 0 value finally. Final value will be 0 after some time, but initial value will be I0, total current. Right? But any current at any time is I, and remaining current is I0 minus I. These are the currents at any instant of time. Not initially, not finally. It is instantaneous values of current through the resistor and through the inductor. What is the question? The question is how much heat is generated through this resistor from initial time to final time, from initial t is equal to 0 to any time after long time. After a long time, how much heat has been generated in the resistor? That is our question. Here, you have a formula for power. You have a formula for heat generated. That is power into time. Power into time. But here, that formula is not directly applied. It cannot be applied directly because current through the resistor is not constant. I square R is not constant. Power is not constant. So we need to use integration calculus for the heat generated in the resistor. First of all, I want to know what is how much is the current passing through the resistor. Current at any instant. I know the current at two instants, initial instant and final instant. At initial instant, the current through the resistance is maximum. That is this total I0. But finally, the current through the same resistor is 0. So I have to find how much heat is generated from heavy current to 0 current. Finally 0 current. Now, but I want to find this I, current at any instant of time, not at t is equal to 0, not at t equal to infinity, at any time. So how to do it? The potential difference between these 2 points and between these 2 points is the same because these are parallel elements. So what is potential difference across the resistor R? That is IR is the potential difference across the resistor. But same potential difference across the inductor, that is the induced EMF, that is equal to L d by dt of current, L di by dt, but that is the current is I0 minus I. This equation we wrote, why? Because the potential difference across the resistor and across the inductor is the same. And across the inductor, the potential difference is induced EMF. Because of the varying current through the inductor, varying current through the inductor varies, that proves the potential difference. But that potential difference has always to be equal to the potential difference across the resistor because they are parallel elements. Okay, now here let me solve this for I, current through the resistor. It will take me a while. So it is IR equal to L. इसका डिफरेंशिएशन 0, तो इसका डिफरेंशिएशन हो गया माइनस डी आई बाई डी टी. सो इट इज, इसको शिफ्ट कीजिए, एल डी आई बाई डी टी प्लस आई आर इज इक्वल टू 0. That is separation of variables. I mean, current is taken to be left side and remaining time variable should be taken on the right side. That is what you call as separation of variables. When we solve differential equations, we have to separate the variables. How we do that? So it is di, ये वाला, divide by I is equal to, इसको shift कीजिए, dt ऊपर आएगा और r ऊपर आएगा और ये l नीचे आएगा with a negative sign. You can check it out. You are dividing l on both sides, it will give the same way. di, I यहाँ पर, dt इधर, l इधर और r इधर. Okay, so this is a differential equation. Let me solve it by integrating. I want to integrate this equation to solve it for current. So integrating it, so integration of, integrate the equation. Don't forget that I have to find, you see, I have to find how much is the heat generated in the resistor. Total heat generated in the total time interval from 0 to infinity time, after long time. So it is integrating di by I is minus r by L integration dt. I'm integrating. But what are the integration limits? What was the initial current through the resistor? That was the maximum, I0. And what is current at any time, after any time? Well, let me say again it is I after any time, but it should have been, it was better if we write prime, and I here. Does not make any much difference, 0 to t. So here I will get current at any instant of time. Although I know the two values of current through the resistor, that is initially the current is maximum, that I0, and finally the current is 0. But I want to find current at any instant of time. ठीक? Okay. Now it is ln I under the limits I0 to I minus R by L. It is t under 0 to t. Okay. Now this is when you substitute this I and I0, so ln of I minus ln I0 is equal to minus R by L t minus 0. So it is ln of I by I0 is equal to minus R t by L. Okay. Now giving anti-log to both sides, or shifting this to the anti-log, that is I by I0 is equal to e raised to power minus R t by L. Okay. Now what is I? What is I? The current through the resistor I is equal to I0 e raised to power minus R t by L. This is the current through the resistor. Now, if you, let us check it out, current through the resistor. At t is equal to 0, e raised to power 0 is 1, I is equal to I0. So, at time t is equal to 0, current is I0. When t tends to infinity, after a long time, the flux through the inductor remains constant, it becomes a short, and all the current is bypassed by the inductor. Total current is bypassed through the short, and the current through the resistor will be 0. So here also it shows the equation, if t tends to infinity, e raised to power minus infinity tends to 0, so current is 0. So this equation also tells you the same physics that you put in. Initially, the initial current through the resistor will be maximum, I0, and final current through the same resistor will be 0. Right? Okay. Now, how to find the heat generated in the resistor? We know what is the heat generated. Generally, what you write? This is the equation that you write. Let me show you certain things here in the bracket, here in this box. You know, power is equal to, okay, dH by dt, heat produced per second. that will be dH is equal to P dt. Integrating, when you integrate P dt, okay, this is delta H, heat generated, or H is equal to integration P dt from 0 to T. This is the equation for heat generated. If we want to use calculus, because here we need to use calculus, why? Because power through the resistor is not constant. अगर पावर कांस्टेंट होता तो पावर को बाहर निकालकर PT हो जाता है, P इंटू टाइम. लेकिन यहां पावर जो है वो कांस्टेंट नहीं है, so you can't get this P out of this integration. So this is the equation that we use when power is not constant. How could power be constant? Because power is I square R. तो रेजिस्टर के थ्रू जो I है वो कांस्टेंट है नहीं. So power is not constant. When power is not constant, you can't use a simple equation, heat produces power into time. That was a simple equation that we use generally when power is constant. But when power is not constant, you can't use that equation, simple one. You have to use equation from calculus. You have to use this equation. So heat generated is integration, initial time 0, final time, okay, after long time, infinite time, P, that is I square R, this one, into dt. So it is H equal to, okay, 0 to infinity. What is I square? Square this, that is I0 square e raised to power minus 2R T by L square. इसका भी square वो 2 हो गया यहाँ पर, इसका square ये हुआ R dt. तो H equal to, constants को बाहर निकालिए, that is I0 square और इंटीग्रेशन किसका? इस एक्सपोनेंशियल का, dt. अब इसका इंटीग्रेशन चाहिए मुझे, ठीक, ओके, इसका इंटीग्रेशन चाहिए टू फाइंड द हीट जनरेटेड इन द रेजिस्टर. ओके, H इक्वल टू I0 स्क्वायर R. जरा इसका इंटीग्रेशन बताइए एक्सपोनेंशियल फंक्शन का. वही होता है इंटीग्रेशन फंक्शन का, वही इंटीग्रेशन है जो भी फंक्शन खुद है. एक्सपोनेंशियल जो है L T बाय इस T का जो है कोएफिशिएंट, इस T का कोएफिशिएंट डिवाइड करना पड़ेगा 0 टू इंफिनिटी. एक तो ये एक्सपोनेंशियल फंक्शन पूरा लिखना पड़ेगा, दूसरा इस t का कोएफिशिएंट नीचे डिवाइड करना पड़ेगा. दैट इज द इंटीग्रेशन ऑफ एक्सपोनेंशियल फंक्शंस. दैट इज हाउ वी डू इट. अच्छा, तो अब ये h इज इक्वल टू, ओके, L ऊपर, ये L ऊपर और 2R नीचे. नेगेटिव साइन ये जो है यहां पर लिखा जा सकता है, इस नेगेटिव साइन को. अब e रेस्ट पावर t को सबस्टिट्यूट कीजिए माइनस इन्फिनिटी. अब इस t को 0 सबस्टिट्यूट कीजिए. सो h इक्वल टू माइनस r कैंसिल हुआ 1/2 L I0 स्क्वायर, 1/2 ये I0 स्क्वायर और ये L पूरा लिखा. तो e रेस्ट पावर माइनस इन्फिनिटी होगा 0, e रेस्ट पावर 0 हो गया 1. तो इट इज H इक्वल टू, ये माइनस और ये माइनस प्लस हो गया, 1/2 L I0 स्क्वायर. दैट इज द आंसर. सो द हीट जनरेटेड in the resistor is 1/2 L I0 square. The heat generated in the resistor is 1/2 L I square from initial time 0 to final time till the current builds up, till the current finally bypasses through this inductor. Initially the current was I0 through the resistor and finally through the resistor current is 0. But during the time the current varies from I0, the maximum current initial, to final 0, the heat generated in the resistor will be this much. This was one more problem for those who who aspire to become IITians and those who want to appear in the what you call as Olympiad exams. And here I again ask you to download my app, Tantray Sir Physics Classes, and also don't forget to watch my lectures on the YouTube. And presently we are at these challenging problems. Every day I try to upload one challenging problem. Some of the problems may be challenging, more challenging, less challenging, some may be even simple, but we have to do the whole spectrum of problems from simple to more and more complex. And also, presently I am discussing and doing gravitation with the students. So don't forget to watch my lectures on the YouTube and subscribe to my channel, Tantray Sir Physics Classes. Thank you.